Poka Yoke, mistake or error proofing. Introduction of Poka Yoke. Poka means errors. Yoke or yokeru means to avoid. Benefits of implementing Poka Yoke in processes. Everyday examples. Everyday examples. Everyday examples. Everyday examples. Everyday examples. Introduction of Poka Yoke. Mistake proofing or Poka Yoke methods are not new to industry. In the 1960s, Mr. Shigeo Shingo first utilized the term Poka Yoke to describe industrial processes designed to prevent human errors. Shingo made a distinction between the idea of unavoidable human mistakes and defects in manufacturing. Shingo stated, defects occur when the mistakes are allowed to reach the customer. In other words, the mistakes made by operators during production become product defects in the eyes of the customer. The goal of Poka Yoke is to design the process so that mistakes can be prevented before the fact, or detected and corrected immediately, thereby eliminating defects at the source. Why we need to implement Poka Yokes. To achieve the highest levels of quality in our products or processes and reduce cost, we must reduce errors and prevent defects. Errors and defects incur very high costs in many industries through wasted production time, rework, and increased scrap. Reducing or eliminating errors in a process can be achieved by either adding more detection controls, i.e., additional inspections, special tools, expensive test equipment, or through the implementation of preventive controls. Implementing mistake proofing or error proofing devices are often less costly than most detection controls. In addition, error proofing reduces or eliminates risk in the process by preventing failures at the point of origin, prior to further expensive processing. The age-old saying, an ounce of prevention is worth a pound of cure, is just as true today. The 1-10-100 rule states that as work moves through a process, the cost of correcting an error increases by a factor of 10. In other words, for every dollar invested into prevention controls, it would cost 10 times that for detection and 100 times more if the customer detects the error. Activity cost. Order entered correctly $1. Error detected in billing $10. Error detected by customer $100. Dissatisfied customer shares the experience with others. The costs is $1,000. Relationship between processes and quality defects. Almost any business activity can be considered a process. Production processes involve the flow of material. Machining, assembly, and packaging are typical production processes. Business processes involve the flow of information. Financial planning, purchasing, and order entry are typical business processes. All processes have the potential for defects. Hence, all processes offer an opportunity for the elimination of defects and the resultant quality improvement. Why we need to implement Poka Yokes. There are many situations or circumstances when application of mistake proofing would be beneficial. Mistake proofing should be applied when there is sufficient risk in the process so that failure would adversely affect the customer. Mistake proofing should be applied when heightened alertness is required while performing manual operations. Errors early in a process are causing problems in a subsequent process. Missed operations or other errors could cause a potential safety issue. Operator turnover is high, or retraining is frequently required. Failures occur frequently or the process capability is low. Incorrect placement of components causing errors that result in defects. Process step or human error due to the operator's attention, skill level, or experience can cause defects. Why we need to implement Poka Yokes. There are several locations where mistake-proofing devices or methods are routinely placed within a process workflow. The location in the workflow can affect the level of effectiveness. The very best location for a mistake-proofing device is before the operator or the machine starts the task. Prevent the error by not allowing the process to start unless a particular set of conditions exist. The second best location is during the process step or cycle. Provide feedback or notification to the operator or machine when an error has occurred and physically prevent the part from moving to the next operation. Some applications provide notification that the operation was performed correctly prior to advancing the part. The final location for a device is downstream at an inspection or test station after the operation or process step is complete. In this scenario, we are completely dependent upon detection controls. The objective is to detect any defects prior to proceeding to the next step in the process. The 7 guidelines to PokaYoke attainment. 1. Quality processes. Design robust quality processes to achieve 0 defects. 2. Utilize a team environment. Leverage the team's knowledge, experience to enhance the improvement efforts. 3. Elimination of errors. Utilize a robust problem-solving methodology to drive defects towards 0. 4. Eliminate the root cause of the errors. Use the 5 Whys and 2 H's approach. 5. Do it right the first time. Utilizing resources to perform functions correctly the first time. 6. Eliminate non-value-added decisions. Don't make excuses, just do it. 7. Implement an incremental continual improvement approach. Implement improvement actions immediately and focus on incremental improvements. Efforts do not have to result in a 100% improvement immediately. Different type of human mistakes. Forgetfulness. Misunderstanding. Wrong identification. Lack of experience. Willful, ignoring rules or procedure. Inadvertent or sloppiness. Lack of standardization. Surprise, unexpected machine operation, etc. Intentional sabotage. Poka Yoke and informative inspection. Reactive approach. Check occurs immediately after the process. Can be an operator check at the process or successive check at the next process. Not 100% effective, will not eliminate all defects. Effect in preventing defects from being passed to next process. PokaYoke systems govern the process. 2 PokaYoke system approaches are utilized in manufacturing which lead to successful 0 defect quality. 1. Control approach. Shuts down the process when an error occurs. Keeps the suspect part in place when an operation is incomplete. 2. Warning approach. Signals the operator to stop the process and correct the problem. Control approach or system. Takes human element out of the equation, does not depend on an operator or assembler. Has a high capability of achieving 0 defects. Machine stops when an irregularity is detected. Warning approach or system. Sometimes an automatic shut-off system is not an option. A warning or alarm system can be used to get an operator's attention. Below left is an example of an alarm system using dials, lights and sounds to bring attention to the problem. Color coding is also an effective non-automatic option. Methods for using Poka Yoke. Poka Yoke systems consist of 3 primary methods. 1. Contact. 2. Counting. 3. Motion sequence. Each method can be used in a control system or a warning system. Each method uses a different process prevention approach for dealing with irregularities. 2. Counting method. Used when a fixed number of operations are required within a process, or when a product has a fixed number of parts that are attached to it. A sensor counts the number of times a part is used, or a process is completed and releases the part only when the right count is reached. 3. Motion sequence method. In order to help operators select the right parts for the right step in a process, the sequencing aspect of the motion step method is used. This is especially helpful when using multiple parts that are similar in size and shape. Everyday examples. Q&A, comment below. Thank you.